Our world is in a constant state of change. Forces deep within the earth are always at work, shaping the very ground beneath our feet. In the vast landscapes of Eastern Africa, something truly remarkable is happening. The continent is slowly but surely splitting apart. A great rift is forming, stretching for thousands of kilometers from the north in Ethiopia down south to Mozambique. This immense tear in the Earth's crust is known as the East African Rift. It's a place where the planet is literally remaking itself. For those who live here, the signs of this grand geological drama are becoming part of their daily lives. It is a slow process, one that takes millions of years, but its effects can be seen today. This massive split is what scientists call a continental rift. Imagine pulling a piece of toffee apart. At first it stretches and thins in the middle. Then, cracks begin to appear. Finally, it breaks into two separate pieces. This is very similar to what is happening to the African continent. The Earth's hard outer shell, the lithosphere, is being stretched and pulled apart by powerful forces from below. As it stretches, the crust becomes thinner and weaker. This causes deep cracks or faults to form on the surface. The land between these faults then sinks, creating a long, low valley. This valley is the rift itself, a new feature on the face of our planet. The East African Rift is not just one single crack. It's actually a complex system of valleys and volcanoes. It is divided into two main branches, the Eastern Rift Valley and the Western Rift Valley. The eastern branch cuts through Ethiopia and Kenya, a dry and volcanic region. The western branch is home to some of Africa's deepest lakes, like Lake Tanganyika and Lake Malawi. These two arms of the rift are slowly tearing a huge piece of the continent away. This piece, which includes modern-day Somalia and parts of Kenya, Ethiopia, and Tanzania, is sometimes called the Somali Plate. It is moving away from the rest of Africa, the Nubian Plate, at a few millimeters each year. This process may seem incredibly slow, almost imperceptible to us, but over immense spans of geological time, these tiny movements add up to create enormous changes. The rift began to form around 25 million years ago. Since then, it has shaped the very geography of East Africa. It has created towering mountains, such as Mount Kilimanjaro and Mount Kenya, which are actually dormant volcanoes. It has also formed the deep valleys that cradle unique ecosystems and diverse wildlife. This is not just a story of geology, it is the story of how landscapes are born, how new habitats are created, and how life itself adapts to a changing world. It's, honestly, a live performance of plate tectonics happening right before our eyes. Scientists are watching this great continental split with intense interest. They are like detectives, gathering clues to understand how our planet works. To measure the rift's movement, they use incredibly precise tools. One of the most important is the Global Positioning System, or GPS. Special GPS receivers are placed on the ground on both sides of the rift. These receivers can detect even the tiniest shifts in the land's position. Over years, the data they collect shows a clear pattern. The land on the eastern side of the rift is steadily drifting away from the land on the western side. These measurements confirm that the continent is indeed pulling apart, centimeter by centimeter. Another powerful tool for watching the rift is satellite technology. Satellites orbiting high above the Earth use a technique called INSAR, which stands for Interferometric Synthetic Aperture Radar. It may sound complex, but the idea is simple. The satellites bounce radar signals off the ground and measure how long it takes for the signals to return. By comparing images taken at different times, scientists can create detailed maps showing how the ground has moved. They can see where the land has risen, sunk, or shifted sideways. This helps them identify active faults and areas where underground magma is moving, all without ever setting foot on the ground. Geologists also study the rocks themselves to read the rift's history. By examining the layers of rock exposed in the valley walls, they can learn about past volcanic eruptions and earthquakes. They look for clues in the types of rock and the fossils they contain. For example, layers of volcanic ash tell them when ancient volcanoes erupted. The alignment of minerals in the rocks can even reveal the direction of the magnetic field at the time the rocks formed. This is like a geological compass, showing how the land has rotated and moved over millions of years. Every rock, every fossil, is a page in the Earth's autobiography. These methods all work together to paint a complete picture of the rifting process. GPS tells us how fast the plates are moving today. Satellites show us the broad patterns of ground deformation. And geology helps us understand the long history of the rift, stretching back millions of years. By combining these different sources of information, scientists can build models to predict how the rift might evolve in the future. They can identify which areas are most at risk from earthquakes or volcanic activity. This knowledge is not just for scientific curiosity. It is essential for helping the people who call this dynamic region home. The effects of the rift are not just visible to scientists with special equipment. They are plain to see in the landscape itself. As the crust stretches, it creates spectacular scenery. Long, deep valleys with steep sides, known as grabens, are the most obvious feature. These valleys can be tens of kilometers wide and hundreds of meters deep. They are home to many of the region's famous lakes. Some of these lakes, like Lake Turkana in Kenya, are alkaline and shallow. Others, like Lake Tanganyika, are incredibly deep and hold a vast amount of fresh water. These lakes are forming in the low-lying ground, created as the continent pulls apart. Volcanoes are another dramatic sign of the rift's activity. As the crust thins, hot molten rock or magma from deep within the earth can rise closer to the surface. Sometimes, this magma erupts, forming new volcanoes. The Afar Triangle in Ethiopia is one of the most volcanically active places on Earth. Here, the ground is covered with dark, recent lava flows, and steam vents hiss from cracks in the earth. Volcanoes like Erta Al have a permanent lava lake bubbling in their crater, a direct window into the fiery heart of our planet. These volcanoes are the building blocks of a new crust that will one day form the floor of a new ocean. Sometimes the changes happen very suddenly. In 2018, a massive crack suddenly appeared in southwestern Kenya after heavy rains. The fissure was several kilometers long and in some places more than 15 meters wide and 15 meters deep. It sliced through a major road and forced people to abandon their homes. This event was a startling reminder of the powerful forces at work. The crack followed the line of a hidden fault, part of the larger rift system. The heavy rainfall simply washed away the soft soil on the surface, revealing the deep fracture in the rock beneath. It was a dramatic glimpse of the rifting process in action. These visible changes show us that the Earth is not a static place. It is a living, breathing system. The formation of new valleys, the growth of lakes, and the eruption of volcanoes are all part of the same grand process. For the wildlife of the region, this changing landscape creates new challenges and opportunities. For the people who live here, it is a constant presence. Roads need to be rebuilt, and houses need to be moved. The ground itself is unstable. Living in the East African Rift means living with the knowledge that the land is slowly, but unstoppably, being torn in two. It is a unique and powerful connection to the deep forces that shape our world. To truly understand what is happening in East Africa, we must look beneath the surface. The process of creating a new ocean begins deep within the Earth's mantle. A plume of exceptionally hot rock is rising beneath the continent. This heat causes the overlying crust to bulge upwards and stretch, much like a balloon being inflated. As the crust stretches, it becomes thinner and weaker. This allows hot, molten magma to rise up and fill the cracks. This injection of magma acts like a wedge, pushing the two sides of the rift further apart and accelerating the splitting process. This process is what scientists call seafloor spreading, but it is happening on a continent. First, the continental crust must break completely. As the rift valley continues to widen and sink, it will eventually drop below sea level. When this happens, water from a nearby sea or ocean will flood in. In the case of the East African Rift, the waters of the Red Sea and the Gulf of Aden will likely be the first to enter. This is already happening in the Afar region of Ethiopia, which is one of the lowest and hottest places on Earth. Parts of this area are already below sea level, held back from the Red Sea only by a narrow strip of land. Once the valley is flooded, a narrow sea will form, similar to the Red Sea today. At this stage, the process changes. The continental crust has split, and a new type of crust begins to form in the middle. Magma will continuously well up along the center of the new sea, creating a long underwater mountain range called a mid-ocean ridge. As this new crust is created, it pushes the older crust on either side outwards. This is the engine of seafloor spreading. The new sea will slowly widen, year after year, as more and more oceanic crust is generated at the central ridge. This is precisely how the Atlantic Ocean was born. Around 200 million years ago, the supercontinent of Pangaea began to break apart. A great rift formed between what are now South America and Africa. For millions of years, the land stretched and thinned, just as East Africa is doing today. Eventually, the rift broke open and the ocean flooded in. A new mid-ocean ridge formed and seafloor spreading began. Over millions of years, this process pushed the two continents to their current positions, creating the vast Atlantic Ocean that separates them. What we are witnessing in Africa is the very first chapter in the story of a future ocean. The slow splitting of Africa has real consequences for the millions of people who live along the rift. The ground is unstable, and earthquakes are a common occurrence. Most are small, but the potential for larger, more damaging quakes is a constant concern. Infrastructure is particularly vulnerable. Roads, railways, and pipelines that cross the rift must be carefully designed and maintained to withstand the ground's movement. The large crack that appeared in Kenya in 2018 severed a key highway, disrupting trade and travel. Engineers now face the challenge of building bridges and roads that can adapt to a landscape that is actively pulling itself apart. Planning for the future in this region requires a deep understanding of geology. Scientists are working to map the active faults in detail to identify which areas are at greatest risk. This information is vital for city planners and governments. It can help them decide where it is safe to build new homes, schools, and hospitals. It also helps in designing better building codes to make structures more resistant to earthquakes. Furthermore, the rift's geology offers opportunities. The same heat from below that drives the rifting process can be harnessed for geothermal energy, providing a clean and sustainable source of power for the growing populations. Looking further into the future, scientists predict that the rifting will continue. In several million years, the eastern horn of Africa will completely separate from the rest of the continent. A new, narrow ocean will connect the Red Sea to the Indian Ocean, turning what is now the Great Rift Valley into a new seafloor. A large island, comprising parts of present-day Ethiopia, Somalia, and Kenya, will drift out into the Indian Ocean. The map of the world will be redrawn. This is not science fiction. It is a forecast based on the movements we can measure today and our understanding of how planets work. Watching the birth of a new ocean in Africa is a profound experience. It reminds us that the Earth is a dynamic and ever-changing planet. The continents we see on our maps are not fixed. They are temporary arrangements on a long journey. By studying the East African Rift, we learn about the fundamental forces that have shaped our world for billions of years. This knowledge not only helps us prepare for the challenges of living on an active planet, but also gives us a unique perspective on our place in geological time. We are privileged witnesses to one of the Earth's greatest creative acts, the making of a new ocean.